In the field, when we move to your differential lines or the tester lines, we can now quite clearly see the ones that we've seen in the greenhouse, how well are they expressed in the adult stage. And again, this would not have been possible if we didn't have the appropriate isolates to work with. There are also some genes that are controversial. And you may have picked up that we talk about in the UG99 race group, we talk about TTKSK, but we also have a race in South Africa that's virulent on SR31. It's called PTKST. So we have a T there and a P there. Now the T is easy to remember. It's virulent on all 4 differentials in the first set. The P means it's avirulent to the second entry, which is SR21. Now, in these pictures, we have SR9H, SR21, SR24, SR31, SR36. So you can see both isolates are avirulent on SR9H. You can argue that this one is more avirulent than that one, probably. You look at SR21, that looks fairly susceptible. And that one looks like a high intermediate to me. It's low because of the necrosis and chlorosis you see surrounding the pustules. But for the untrained pathologist, it will be very difficult, I think, to distinguish between that one and that one without knowing what you're looking at. So now it is, again, we have the appropriate cultures. We can go to the field and test this. And this is the adult plants of that particular seedling leaf I just showed you. That's a susceptible control on the right, and those 4 or 5 plants are from SR21 in the Chinese spring background. And you can clearly see that the P is the correct notation for this particular race, the one that we have. I have not done the same for the T race because it's difficult. I don't have the luxury of having single race nurseries. But I think that will also answer some of these questions, if we can do this. And also when you test it in the diploid in einkorn, you can see that it is completely avirulent on that particular entry. Another controversial gene, it's not really controversial, we know it's ineffective, but if you read Dr. Jin's article, you will see that he wasn't sure of what SR9D does in the field. You can see it's susceptible, but it's got a lower severity, and I've seen this over many years. So that's another way that we can accurately describe the expression of certain SR genes. This is in the Wernstein background. Obviously, if you put SR90 in something else, it may be 100S. But again, the availability of cultures resulting from surveys allow us to make these detailed tests, and then eventually we can make more informed decisions about which genes to use. So recently, as a result of the DRRW project, I've been testing several sets of germplasm for many people around the world, and this just in South Africa. If you go to a bigger institution, bigger lab like CDL, or to Canada, they have tested many, many more. So this is just an example of how the information feeds into, hopefully will feed into breeding. I test our local germplasm, as I've mentioned. I tested an extensive triticale collection for the USDA at CDL. And that's been published against UG99, but also against our triticale attacking isolates. We have 3 isolates, highly virulent on triticale, and it's been quite informative to add that to the UG99 data. Tested some wheat-rye substitution lines for a student in Sweden. Also with our triticale isolates, you will remember some of the pictures I showed on Sunday with a very atypical X on the right. We have the flex with the large susceptible pustules in between. That was part of that project. I've been assisting Dr. Wolf and co-workers with the Agelop sharonensis accessions from the UK, as well as segregating populations. And then also with that particular resistant sources were integrated into wheat by Dr. Eitan Millet from Tel Aviv University. I've assisted him for several years in selecting resistant lines, and I'll show you some pictures now how that has evolved. I'm testing agropyron. Not sure, Devinda, you seem to be the expert, whether it's agropyron or thinopyron. I don't know. Agropyron. I've been assisting them within the DRRW project to test their materials, and we continue our collaboration in that regard. I've been testing barley accessions for Dr. Stephenson in the US as another site, also with a UG99 race member, and then just going to more pure varieties or land races, Australia, Nepal, Bangladesh, Zimbabwe. We also tested the Zimbabwe panel for leaf rust, and then currently I'm involved in testing for SR9H in material from the USDA at Aberdeen, as well as from North Dakota State University. And all of this is a result of the availability of particular cultures or isolates collected during surveys and preserved, purified, and which can now be applied to rate certain important germplasm collections and then use that information towards breeding.